Hey everyone, and welcome to The Index, brought to you by The Graph, where we talk with the entrepreneurs building the next wave of the internet. I'm your host, Alex Kahaya, and in today's episode of The Index, I'm thrilled to welcome Nicolas Kokkalis and Chengdiao, the co-founders of Pi Network, the first digital currency that can be mined on your phone. We will learn all about how Pi differs from other crypto projects, their approach, and the utility that they're building. Welcome to the show. Thanks for being here.
Thank you for having us, Alex.
Thanks, Alex.
So I would just first love to learn more about you guys. Like, how did you meet? How did you get the idea for Pi? Like, what is the genesis story for in your backgrounds?
Pi Network is a combination of our academic and also personal interests. Nicolas and I got to know each other a long time before we built Pi. So he is always a hardcore computer scientist, from hardware to theory or distributed system, which is a precursor to blockchain and later human-computer interaction. I am a social scientist. During my second half of my PhD at Stanford, I also got interested into human-computer interaction. So that's where Nicolas and I collaborated many years on multiple projects in social computing, crowdsourcing, building large-scale systems, design systems for scaling human communication and productivity. We wrote a few papers together. And then we both are interested in entrepreneurship. So we combine all these interests together. Pi combines all these interests I mentioned above. And to solve human interaction, facilitate large-scale participation and collaboration to create something larger than, just the people combined collectively. And then we think blockchain is a very powerful technology to facilitate that. And we look into the solution in that space. And actually, Nicolas was even teaching a class on decentralized applications on blockchain. And through that experience, we discover, certain issues of the industry at the time.
Especially through that experience, we were very frustrated with the current limitations and implementations of the crypto industry at the moment. We initially tried fixing the user experience problems that some other platforms had. Soon we realized that without actually building our own platform, we would not be able to create a truly decentralized and truly accessible cryptocurrency for people to use. So that's because fundamentally people would not have been able to mine it themselves without upfront financial costs. We ended up designing Pi to address all these issues, and we aim to have accessibility, inclusivity, and wide distribution on a large social network that recognizes Pi and this way allows true utility to emerge.
Really interesting. And it's all done on the phone. One of the things you guys are trying to accomplish is just lowering the barrier and to make it more accessible. And I think that's been the holy grail of crypto for a while. Like, I remember I got back in this space in 2016 and that was the narrative then. And it's still the narrative now. It's still a work in progress. There's like a lot to be done, but I'm just genuinely curious to learn more about your approach to solving that problem. Let's go a layer deeper and talk through what it actually looks like, what Pi does, and how it brings that user experience problem and accessibility problem, fixes that.
Yeah, accessibility has multiple aspects. There is the financial barrier, there is knowledge barrier, there is also the easy to use or, the technical logistic barriers. So in order to achieve true accessibility, you need to solve all these barriers in order to break down all the barriers and have a free flow of user experience. And that's what Pi trying to address those issues. So specifically, have a phone that is accessible. Almost these days, everyone can have a phone. And also accessibility is about equal opportunity. So it's free. Everyone can just go to the App Store and download. And then, easy to understand, meaning that people don't have to have a CS degree in order to know how to run a node to mine, but they can use a phone and an app. And building the user experience easy enough for them to follow. The education of the whole process of what is mining, how you can mine, this is also important.
I would love to dig deeper into the consensus or just how that works. From a mining perspective, that is definitely one of the biggest things, like especially for early adopters, that you miss out on. If you're not highly skilled DevOps engineer in most cases, you cannot participate at that level in the earliest days. And a lot of that has to do with the software, right? The validator software and how complex the the algorithms are or whatever to validate and to set up that validator. So how does it work in your system? Like, it sounds like you get set up really easily, but like under the hood, I'm curious to learn more about that.
The essence is a different type of consensus algorithm, right? In terms of how it works, if you compare it to Bitcoin, everyone knows Bitcoin uses proof of work. Let's compare to Bitcoin. Like Bitcoin, Pi is also running on its own blockchain. So it's a layer one solution. We are not running on other people's blockchain. Unlike Bitcoin, we use different type of consensus algorithm. Bitcoin uses proof of work. The requirement for that consensus to run is contributors or miners contributing energy and electricity. And in return, they receive Bitcoin rewards. In Pi's case, we use federated Byzantine agreement. In Pi's specific blockchain, it actually relies on a trust graph. The trust graph is an essential component feed into the blockchain for it to reach consensus. So the mobile miners are actually contributing to this trust graph that the blockchain will use in order to secure the ledger. So each mobile miner actually are contributing by their trust circles. We call it security circles, which is they appointing 3 to 5 people they trust. And in aggregate, millions of people's trust circles forms this trust graph that will be used by the blockchain and to scale. So the mining in analogy is Pi's consensus algorithm requires the trust graph and contributors or miners contributing to the trust graph in return receive Pi rewards. This is the fundamental reason why Pi mining doesn't consume the level of energy required by traditional mining of cryptocurrency. At the same time, it's also allowing mobile miners to contribute to the blockchain without getting, with abstraction also from the complications of the technical aspect of blockchain.
So I have 5 friends and I onboard them to the Pi network as part of my trust graph. I like send them the link to the app. They download the app and they hit the button to contribute resources. How is the trust verified? I guess another way to ask is like, how would you game the system and how do you prevent that, right? So what does trust actually mean and how do you, at a scale, I kind of see it already, right? Like if everyone's trust circle is 30 people, that's still not big enough to be like the billions of people they can't possibly collude to corrupt the chain. I'm trying to wrap my head around like what are the risks and trade-offs and like how does it actually work? How does the trust actually work?
Yeah, I can try to explain intuitively how this works. First of all, I want to clarify that the blockchain consensus algorithm is running on computer nodes, and we have tens of thousands of these computer nodes already, or even just on our testnet. So comparing the testnet of Pi with other mainnets is a few maybe orders of magnitude even bigger. Now, the mobile miners, what they are contributing is those connections that you mentioned, the trust. So intuitively, this helps isolate any potential, it's called Sybil attackers. Sybil attack is when someone is creating fake accounts to pretend he's more than one people on the network. So think of it intuitively. If me, you, and Chengdiao are the only people on Pi network and no one else yet, and we point at each other because we pulled out on the phone each other and selected them and we say that these are the people we trust. Now, if a 4th person comes along and creates, even if they create 1,000 fake accounts, the best they can do is they can have those accounts pointing at each other. But in order for us, for the 3 of us right now, to trust that those fake accounts, we would need to be convinced to change the trust pointers that we have from each other to those fake accounts. And why would we do that? So now imagine take this idea to millions of people, you will understand how it works. In its essence, it's similar to the original Google PageRank algorithm, where you have web pages on the internet and the true web page of MIT is pointing to the true web page of Stanford. And it doesn't really matter in the end of the day.
It's the authority that's built from backlinks is kind of the idea.
Yes, exactly. So you could have fake blogs pretending to be Stanford, but no one cares.
So let's use the web page example. Let's say I'm like a web page that's rank 1 on like a high trafficked search. I have a lot of weight because I have a lot of trust. Like I have 1,000 people pointing to me and those people are not fake accounts. Does that mean I mine more of the currency because I have more? Is it like proof of stake kind of like that? Or how does that work?
No, we didn't want to make it on the plutocratic side. So the mining rate is standard across everyone. There are certain bonuses depending on different contributions.
Basically, the trust graph give rise to the better formation of the quorums of the nodes. And quorums are basically a subset of the whole node network within which the nodes are, messaging each other in terms of voting whether a transaction is true or not. And each time the quorums are dynamically formed. So it's not just always that set of nodes. That's why it's to some extent more decentralized in a way, because each dynamic quorums is formed independently. And within the quorum, nodes message each other and reach consensus. And the algorithm basically can ensure finality to this transaction and get recorded on the ledger.
And so you mentioned that you have 10,000 of these nodes. Is that 10,000 people with their phones? That was my understanding, but is it different than that? Are they actual computers? They're phones in the sense that your phone is a computer.
Yeah, if you're referring to the blockchain running to the devices that are running the consensus algorithm to produce blocks, these devices are only computers at the moment, not phones. We don't think that it would make sense for phones to be doing this kind of job. And in fact, I mentioned that there are tens of thousands. I need to look a little more into giving you a more authoritative answer of how many of those we have, but some unofficial survey we did recently gave us more than 90,000 nodes on the network. These are the computer nodes.
Yeah, and that's just like laptops, like anybody's laptop could.
Laptops, yes. So that essentially, if you look at this large number, even just on the testnet, it makes Pi network one of the largest distributed systems on the planet. Not just a blockchain, distributed system. Any system that doesn't have a essentially centralized server. There's a lot of different kinds, like file sharing, including is a distributed system.
And so you have a testnet. You haven't launched mainnet yet. What's sort of the status of where you are in building all this out?
Our mainnet is live. We launched the mainnet. This goes to also your question about what we are different from other blockchains. We are taking very non-consensus type of approach. Our mainnet is live, and we actually created a special period. It's called enclosed network period. This is a special phase inside our mainnet where the mainnet is live, but it artificially put a firewall against any external connectivity. This is to ensure that we can focus on building utilities within our ecosystem. And we believe their utilities can be built in the enclosed environment. Of course, recognizing there are certain utility requires external connectivity, but we want to focus on building utilities within this enclosed phase in order to get the utility-based ecosystem more mature before we open up to an open network where the firewall will be removed. In addition, during this phase, as you know, our network is not just a few thousand people or participants. We have millions of pioneers all over the world. So in order to onboard these millions all into the network, it makes sense and more fair for majority of the network migrate to the mainnet in the enclosed environment before opening up. This is also another goal of the enclosed network in addition to creating utility within the enclosed system. And this is also, the answer to your question, what is so different from other crypto projects? I think this is an innovative phase we created.
Yeah, it's just kind of gated. I mean, you let a bunch of people sign up and then you sort of gate the mainnet access. It's permissioned right now, but you will be an open permissionless chain once you feel like you've kind of made it out of this period and you have enough utility.
Yeah, during this period, as we mentioned earlier, there is more than 45 million engaged members on Pi network right now. We call them pioneers. We are in the phase of accomplishing KYC for them and transitioning them to the mainnet. The mainnet you see on the Block Explorer is the real mainnet that will continue when it's open. Right now, we've KYC'd over 5 million people, and that's one of the goals to make the migration.
Yeah, this choice of this strategy is also based on Pi's philosophy of inclusivity, right? Our requirement of KYC is also making sure that all corners of the world regions are able to KYC and get onto our mainnet. This period supports this process.
I have so many questions. Just to take a step back, the utility you're building, can you give me examples of what things you're building on top of Pi network and the examples plus the impact? Like, you've obviously prioritized some things that are gating the launch of the permissionless network. And so I'm kind of curious, like, what are the things and what is the impact? Once you have these things, why do you need them to wait to be permissionless?
Yeah, so utility is decentralized efforts from the whole community, not just the core team. Of course, we play a big role inside that by providing the infrastructure that facilitating the decentralized efforts, such as providing the platform, the SDK, and developer tools. However, the actual building and the honing on the real true utility for human to solve human needs is a completely a collective effort from the community builders and also community users of those apps. We have ourselves built some apps. For example, just now I already mentioned the KYC app. The KYC app, because also following accessibility, we didn't outsource to a third party, which usually charge at least $1 for doing a check, right? So that actually we develop a native solution that not only solve the scalability and also wide distribution of the geographic locations, but also it doesn't require people to pay out of pocket cost. Pioneers actually pay Pi cryptocurrency for the labor or the work done by the, crowdsourced human validators within the community to perfecting the validation process where the AI or machine automation lacks. AI advanced a lot, of course, but, for identity verification, there are cases that still needs human touch. And that human touch was provided by the community itself. So actually pioneers are working as validators, are actually making Pi from the pioneers who want to verify their identity. So this is a true utility using Pi, meaning that the Pi is used to facilitate transaction between the labor of the validator, work of the validator, and result in actual substance, which is whether someone is verified or not.
So you guys built a custom KYC solution?
Yes, we did. We have to because, even the market providers don't necessarily provide KYC in, for example, regions that are really small or have a smaller market because most of the KYC providers are, profit driven. Building the infrastructure for a specific small region really costs a lot for those businesses. But for Pi, in order to really achieve inclusivity, we have to provide KYC solution to all regions where our pioneers exist. So we designed innovatively this design that scalably to cover all geolocations while at the same time not costing out of pocket.
So this is super interesting to me because, and just for people listening, KYC stands for Know Your Customer, and it's a really common thing you have to do in this space. Like anytime, just for like a lot of regulatory reasons, it's the best practice to KYC folks for things like grants programs and kind of anytime you're dealing with tokens, you're probably KYCing somebody, especially if it's a permission chain like this is right now. So I see why you're having to do it, but building a totally custom one, that's a huge effort. I've actually built integrated with providers multiple times to automate KYC for things like grant programs. They're checking OFAC databases. They're checking a whole bunch of different things to make sure that, it depends on the level of KYC you're trying to do, but, making sure you're not on a list of countries where you're just not allowed to do business, like North Korea and stuff. What is the process under the hood again? What is running there in the app and how do people verify identity, especially this manual process, it sounds like with pioneers who are doing the work. How does it work? What are they looking into? What's automated, what's not? Just very curious to hear more about that.
Well, it starts as a typical KYC solution, what you would expect. So you pull your phone, you have to show liveness, turn your head, respond to certain prompts. You have to show your ID and the ID is captured and then AI is reading it. You have to fill out certain information, which is pretty standard stuff that all the KYC solutions do. We have a back end layer, which is processing all those things automatically as much as it can. And as expected, there are some cases where and certain questions that the AI has or is uncertain about. And those questions need to be answered. Every KYC solution has to answer them with humans. So what we do at Pi is that we reward existing selected trustworthy already KYC'd members of the Pi network to answer those questions. We also had to add an additional layer of security on this so that what they see is not the raw data of what someone updated. So for example, if someone were to want to verify the the face of someone on an ID versus whatever we got from a selfie picture that they get, then our software is cutting out only the picture from the ID, is cutting out the picture from the selfie, putting the two together and asking a validator to say, are these two pictures the same person? Another use case, and there's multiple of them, will be the last example I'll give, is that if you need to ask certain question about an ID to a human, the software is covering with black reduction boxes all the information on the ID, that all the text that is not supposed to be seen. And it's also cutting out the picture. So when you're showing an ID, it's pretty much fully anonymized, like the picture is missing, the data is covered. It says California driving license. That is not covered. And then possibly the question is does this look like a real California driving license, for example? And then the specific question that a human needed to answer can be answered while trying to preserve privacy and security. Then after this whole process completes, we have to do all the compliance requirements, like you mentioned, OFAC and other things.